Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, I welcome you all to yet another video on the compiler design. Okay, and last time we talked about recursive descent, Parsing, right? And this recursive descent parsing was one of the types of the predictive parsing. Okay, so until now we saw that when we talk about the parsing, either it could be the backtracking, okay, or it could be the predictive parsing, and both of these guys can be, backtracking is also of recursive descent and predictive parsing is also of recursive descent. And we saw the recursive descent predictive parsing, okay, and which uses actually the procedures, and we saw procedures and a lot of things. But before that we need to have a eliminate the left recursion, and also we have to, our grammar have to be left factored, okay, right? So when we are done with this, we can go for the predictive parsing, and we saw a special token the next, which was actually a look ahead. Now the major drawback of the predictive parsing using the recursive descent was the procedures, and the advantage was it was fast, and not actually fast, sorry, that it's very simple actually, okay, to implement, and we can just do a hand coding to implement the predictive recursive descent parsing. So your predictive parsing plus hand coding, that is actually the recursive descent parsing, right? But we can do better, okay, and we want to remove this. Whether we saw the backtracking or we see the predictive parsing recursive descent type, it has the recursion. It uses the stack, but that was the implicit stack, right, which is used for the recursion. But we want to remove this recursion now, so we want to go to the non-recursive predictive parsing, okay. So we want to go for predictive parsing but non-recursive. So how we gonna do that? So for that, what we have is what's called as an LLK grammar. So what is this LLK, and how we gonna do the predictive parsing without recursion? That is going to be the today's topic. So our recursive descent parser encodes state information in its runtime stack or call stack, right? And then uses the recursive procedures calls to implement a stack abstraction. And this actually, stack abstraction may not be particularly efficient because there are a lot of procedures to call to and fro. So we got other implementations as well. Firstly, we got an explicit stack and hand-coded parser. This is the one which is hand-coded, but the most efficient one is this guy, which I talk about today, is a stack-based table-driven parser. Now why we prefer table-driven parser is that tables can be building tables can be automated. So we can use a push-down automata, and we can have the tools which actually build this table for us. So it's going to be very fast and efficient. Now to use this predictive parser, this is actually going to accept LLK language, okay. So we're going to accept LLK language. So the predictive parser accepts this LLK grammars. And what is this L and L? The first L is left to right scan of input, which we were doing right from the beginning, and the second L is the leftmost derivation that also we know, and the K is the K tokens of look ahead. That means how many tokens we will take into account to look ahead. Actually we last time saw the next, okay, and that was we were talking about just a single token. Okay, we say that we will see only one token ahead to chuck our grammar, right? So that's why usually we have, that's why LL1 grammar, because one means one token. We'll see only one token ahead. Okay, so this is also a question that how many tokens we should look ahead to actually predict our production, because we have to predict which production to use. um, and we see maximum context free grammars, there we need only one token. That if you have a one token in advance for a lookup, we can do our job. Now a parser generator often looks like this. So what we have here is a stack. This is an explicit stack. Then we have a scanner referring the tokens, and then we have a table driven parser. This is a driver program in our parser, which actually looks things from the parsing table, which can be generated by some parser generator, automatically done. We have a grammar. We give a grammar to the parser generator. It generates the parsing table. And what in parsing tables we have rows and columns, and wherein we have actually production rules. Which production rule we got to use? On one side we may have the non-terminals like x is y whatever, and on this side we have terminals like, for example, plus. If we what we're gonna do here is that we say that, hey, if we have an x as a non-terminal and in the input we have the plus, which production rule to use? Because if we see in our backtrackings, we use the if else's, or in our recursive descent parson, we use actually the procedures to see which production rule, and here we use this table to see which production rule. So the grammar is actually encoded. It is encoded. Actually, we have a grammar, we encode it into this table, so tabular form. Okay, so this will help, because this can be implemented using an array, so it's a much better implementation. It can be faster lookup we can have, and we can use we can do quickly our parsing, right? So basically we got it's a two-dimensional structure, this parsing table. This is the heart of this structure, right? So what I talk about, this is a one dimension this side, okay, and second dimension this side, and this is actually this dimension is for the next token which we are talking about, right? Which token, say plus or whatever it is. So that is a terminal in our case, in our grammar. So terminals will be here, and non-terminals actually is which at a particular moment which terminal non-terminal we want to expand. So expansion we know using some production. So table entries are actually the production rules. So we have having production, which production rule to use will depend upon which actually non-terminal need to expand on which token. Which look ahead will have particular token in its entry, like for example in the last video we say next, okay, and on the particular production we will say which production to use, okay, because we want to predict which production we will be using exactly. So this is the heart of the thing, and we will be learning how to develop this thing, and for that we will need to know a lot of things. For little visualizations, for example, what will be stack using for, we will have stack, for example, we have here x, y, z, and so on, and there will be also a dollar to say this is the end of the input, end of the things. So this will be on a stack, this kind of things. We will deal it in a detail, but I'm just giving you a kind of visualization. So it will be kind of this. We have a stack, okay. The stack will hold the things like this, and then we have these inputs. This will be input, and we will have a dollar to mark the end of the input. Then there will be the predictive parser here, which is the driver program, and this actually uses a parsing table, okay, which we have to learn how to build it. And this is actually a driver program which actually uses all these things together to get us the output, right? Okay, now this is the buffer, input buffer, okay, which contains a string which we need to be parsed. This is actually the tokens which we get from the ledger, and the stack actually contains a sequence of grammar symbols, okay, and we have then here the driver program which drives everything together, and uses the parsing table as well, okay. and we have also on the stack on a firstly we put up the start symbol and the dollar sign on a stack, and then we start putting on the stack things and working to build our output. Okay, now the action will be done. Basically the parsing table will have the production which production rule to be used. Okay, and the thing is we will see what is on the top of the stack and which input is to be look at maybe having firstly this input A, for example, and we want to see whatever is on the production X's, for example, in the stack, and which production X will use when we have A as an input. Okay, so we'll use exactly that production only. So because it's a predictive parser, we have to exactly tell which production rule, which that's this parsing table which will tell us, and this driver program actually runs all this thing together, and then if they match, we will actually go forward, right, and so on. Because what we are gonna do is we have to only see whether this is in accordance to our grammar rules or not, because at the end of it we will say yeah, it is. Okay, or if it is not, we will have generated some error handling routine. Okay, now here three situations can arise. Number one, that we have a dollar, and on here also we have a dollar. Okay, maybe we have reached it to the end, so on the stack only dollar is left out, and here also the dollar is left out. That means we are done. Okay, so we have a halt. Second situation will be on here, there will be a terminator itself. Say for example this is a terminator A which matches exactly to the input. Okay, then what we're gonna do is we're gonna pop it, we're gonna proceed forward in the input, and we're gonna pop this thing as well. The third thing will be that there is a production rule, there is a non-terminal on the stack, on the top of the stack, because we will be always talking about the top of the stack. Okay, so third rule will be that there will be a top of the stack is some non-terminal. Okay, so in that case this driver program consults the parsing table for this top and this look ahead and see which production rule to use, and according to that we will pop this the top of the stack and fill accordingly what we got to fill on a stack, right? Say for example we have in the parsing table we see that hey, if we have an X and we have an input this A, for example, okay, on this grammar rule M which we talked about, we say that hey, in this case we will use a production X goes to, for example, A, B, C, for example. Okay, then what we're gonna do is we will actually do what? We will replace this X, okay, and put on the stack this ABC in a reverse order, so that C will be on the top. So we put up in it in A should be on the top. So we have to put, say firstly C here, okay, then on the stack we will put B, and then we will put A, so that A will be on the top now. Okay, and here the pointer will be exactly what it was, it will not proceed. Okay, so I'm saying we will have three operations here. The first operation will be actually the last thing. If there is a dollar and a dollar, so we halt. If there is a terminator here and a terminal symbol here, and we have exactly the same symbol here, so that means that is a match. So we will discard this and put pointer forward, and here we will pop that terminator. Okay, and if it doesn't match, that means we have an error. We will actually this driver program will use its error handling procedure, and if it is a match, then it's good. We will move forward and we will pop that. We'll say okay, this is a match. But if it is a non-terminal, okay, if it is terminal it's okay. If it is non-terminal, now we have to use a production rule. Then we consult the parsing table at that moment, and we will see which production rule is used, and we will put those things on the this stack, right? But before we can do anything, okay, we have to build the parsing table. That is, we have to encode our grammar into this parsing table. Okay, so to pull this parsing table, we must first compute first and the follow sets. So what is this first and follow sets? Now let's try to learn these things. So when we understand these first set and follow set, we can how to compute that. Then we can actually can build the parsing table. Okay, when we have a parsing table, then our driver program can use that to actually parse. The parsing table will be used to predict which production rule to be used at a particular for a particular input variable. Okay, and for a particular non-terminal. Okay, so we'll first try to see the first and the follow sets. To understand this, let's take up a grammar where we have a goes to a plus t, which we took last time also. Then we say it goes to the a, and t goes to the small a. Now here we have, for t we've got two productions, for a we've got only one person, so there is not a problem. But all the time we start from the start symbol. Okay, that is a, and we have no choice here but to use a plus and t, only one production rule, so there is no confusion in that. We can do it much easily. But when we're gonna choose the t, when because we know, say for example, last time I told you a plus a, this is the string of input which are we trying to scan and try to see whether this is a match, having is this syntactically correct or not. Okay, and we match this a with the a, then this plus with the plus, then we go to the t, we're gonna expand the t, right? So last time we discussed this in detail. Now look at here, we expand this t, and should we expand it to this production or this production? Okay, let's try and understand why come the first and follow comes in. So definitely I have gone through a, then this plus, so I am done these two things. Now when I'm on a t, because my next input, because my look ahead is saying that the next input is actually the left parent, so the t which has the left parent should be expanded. So this t should not be expanded to a, this t should be expanded to this production where we have a left parent. So that means when we are trying to expand the t, okay, we got to go through into it and try to see what is the first a non-terminal, a terminal, which is what is the first terminal when I go through the t production. Okay, maybe we have a t and it does not go to it goes to a. Okay, and later on a goes to the left parent. Okay, say for this kind of a rule. So I have to go through the t into the a, and from the a I got to see what is the first. After that there could be anything. I'm not worried about that, because to choose between this production and this production, I need to see which first terminator is there. Maybe on this t, for example, there is something b. Okay, and after that a. Maybe the b goes to the left parent, because I am in search of a production from the t which will lead me to this left parent, right? So there's a simple situation here that t goes to directly the first is the terminator there, so it goes there. Okay, so that means I have to go through the t production and try to see what is the first terminal there. Okay, so I'm interested in that. So that is why I will try to in my table, okay, I will try to have the first set for all of these left side production rules, LHS, because when I'm talking about a, I got to see what is the first terminal of that a, and similarly when I go through t, I have to see what is the first terminal when I go through the t. Now there can be many scenarios. Here is the straightforward, the terminal is there, the terminal left parent is there, so I can just see that. But I could have this situation like this, where t does not have on the right hand side a terminal but a non-terminal itself, so I have to go through that non-terminal to get the first. So what I do is I do it in advance. I do all left hand sides and I will see what are their first terminals, and I will keep that in a first set. Okay, so first set of home, first set of all these left hand sides of the grammar. Okay, because I have to decide, you should understand, because I have to decide which production rule I have to use, and I will use what production rule I will use is determined by what is my input symbol here. Okay, and that's going to be the terminal. Okay, so I have to see which production rule. There may be 3-4 production rules of the T, and tomorrow we may have hundreds. Okay, and I have to use out of them which will lead me to this left parent. Okay, so that exactly will tell me the first. Now why we have the follow if we have the first? Because we are always interested in the first only. But maybe the T goes, say for example, it goes to the epsilon. So when T goes to the epsilon, so that means I can't, epsilon means no input, so I have to see what is the next symbol to the what is the next to the first, because first can't be there now, because if T goes to epsilon, that means there is no input. So then I have to see what follows that because in the follow will be my that first non-terminal which I am searching for. Say for example, the example I can give you is like T goes to A, and then there is something like the beta, for example. Now I was trying to see what is the first of the T, because I want to find that terminal symbol where the T, which is the first. Okay, after that it could be anything. I'm not worrying about that. I'm just worrying about the first, that terminal, right? Now I saw that it is an A is itself a non-terminal, but A goes to epsilon. That means A is as good as taking nothing. When A goes to epsilon, that means I can't go from the A to get the terminal, right? That means the terminal I am trying to find is the first, because what is beta? Beta is something combination of terminals and non-terminals. Now the first that terminal which I'm asking searching for will be the first of this beta, right? So that means I have to see what follows this A, and in that first element is actually what I'm trying to find, which is actually which I was trying to say that the first, that terminal which via T I can get. Okay, now to generalize this, we will talk about the rules. The first thing I'm saying is that if we have the two productions for a non-terminal, right, as you could see here, there could be hundreds of the productions for a particular non-terminal, right? Now I have to choose exactly out of them which one I will use. So the productions should be in such a manner, firstly because there should be no elimination of left factoring. There should be it should be left factored, and elimination of left recursion should be there. Otherwise it will be ambiguous, because what will happen by that is the T, that is actually the property of the LL1 grammar, that the first of this production and the first of this production will have no commons. That means if this T goes to, say for example, the left parent is the first non-terminal in it, and this T goes to beta, the B will not have the say B tomorrow will not go to the left parent. It should not be like that, because it will create a confusion, right? So this is what is called the LL1 property. The LL1 property, this should hold true. This is important for us, because otherwise it will again lead to the ambiguity. What is LL1 property? LL1 property is if we have some A, it goes to alpha, and at the same time A goes to beta. That means we are trying to say A goes to alpha or beta. Now alpha is some string of some terminals and non-terminals, and beta can be some strings of terminals, like we had in our example. T goes to, say for example, I don't know what, A maybe like this, and T goes to B and small a, say like this. Now we got the T goes to one production and T is another production. Okay, this is alpha, this is beta this time. The first of this, say for example, if this B goes to something else, say the C, small c, that's the terminal, or say plus E, for example. Now B is going to E. The first of B is plus, so okay, that is here. So that means that will be the first of T as well, because T goes to B, B goes to plus. Plus is actually, if I go via T, the first will be plus. If I go via this tree, the first will be the left parent. So I call this thing as an alpha and this thing as an beta. So that means whatever it is, the first of alpha and the first of beta, that should not be same. That means, in other words, I can say that first of alpha intersection first of beta should be null set. That means it should not be common, because if they are common, so I may not be able to say, because I have my k in an LLK, the k is 1. I got only one look ahead token, which on that I have to decide where I have to go. So because I have only, say for example, left parent, so on the basis of left parent I have to choose out of these 2 or 3 or whatever productions I have to choose which production I will use, right? So that means the first, which actually tells me the first terminal of this production and this production or other productions which are of the T, should not be same. They should be different, right? So this is the LL1 property. This should hold true. If it is not holding true, so my table entry in the parse table will be multiple entries, so I may not be I may not be in a position to decide which production rule I will be using. So my this rule actually allows the parser to make a correct choice with a look ahead of exactly one symbol. Now this property will become a little complicated if, for example, the first of alpha, which I'm talking about here, alpha, the first of it, that means the first can be anything, right? Alpha can be anything, like here is a left parent, a right parent, and there may be many other things also in it. Now maybe this is going to be epsilon, okay, and alpha, the first of this terminal is not a terminal but an epsilon. That means I have to then see the follow of this alpha, right? Then I can, that will be the terminal here, right? In case this T, for example, if this first symbol is epsilon, it is not a terminal, right? Then I have to see the follow of that. That will be my the symbol which I'm looking for. So for example, here it was an epsilon. After that, it is the terminal. And I have to see the follow of this. Say for example, here it was not. It was like this. So say for example, it was T is to A, then after that it is like this, okay, and A itself goes to epsilon, and T is again which says something, what was that I taken here, we take the same as B and small a, okay, and now B goes to plus E, right? This now I got for T, I got two productions. Okay, now here A goes to epsilon. So when A goes to epsilon, I can't say the first of T, because if I say first of T, that's epsilon, that will take me to the epsilon. So I have to see the follow of A here, that is this guy. Okay, that is the left parent. Now this, I can't say here first of alpha here, first alpha, I can't say that, because now if first of alpha goes to epsilon, I have to say then the follow of alpha and first of beta. So I have to say here then the follow of alpha intersection first of beta should not be equal. That will be LL1 property. Okay, let's take another example to reinforce this concept. Let me change the pen to blue. Say for example, I got a grammar S. Let me go down. So let me take a grammar S goes to A S B, or it goes to epsilon, right? So what's gonna be the first of this S? The first of S can be, you know, it is a set which consists of the first of this guy, the first production rule, or the epsilon, right? Because this is the second, because S may go to this or S may go to this, right? Okay. So if you say, in other words, I will say first of ASB, that is the A, and first of your B, that is gonna be sorry, not B, the epsilon is the epsilon. Okay, so now if you have a grammar like this, we have T goes to int, or int into T, or this thing. Okay, now what is the first of T? Leave this thing. You can have any many after that. Let me have only two things to concentrate on my concept. Now if what is the first of T? The first of T will be, if I say first of T, now in my previous example, this is gonna be the alpha and this is gonna be the beta, right? Now what is the first of T? It is gonna be int, because this is the terminal, because we have got a two productions for T, either int or int into T. Now again it's int. So this is a problem, because we have two things here, the int and the int. So that's what we say, the LL1 property is that they should be distinct. So they are not distinct, so this is not LL1 grammar. That's why we got to do left factoring for this. This is the reason why we do the left factoring, because it will become ambiguous, because it will have two entries for a single production. In our case it should be unique, and that's in only case where we have, we can choose out of which production we should be using. So if we have an int as an input symbol, we will not be able to say whether we should do this or we should do this, right? That's why we should have the left factored grammar. Now let's take an example of this. This is the left factored grammar, so there is no problem in it. So we have to find what is the first of all the non-terminals. Okay, we will also be interested in first of terminals, but that will have no use, because first of terminal is that exactly that. Because what is the first of E? We are trying to go from the E production and try to see where the terminal comes, the first terminal, where that production. Then we have the terminal itself. Its first will be that terminal only, right? Okay, so if I say here first of E, for example, I want to find the first of E. Okay, now first of E is, if I go through this production and I see there is a T. Now what is the first element of the T? That is actually the first of E. So before I find the first of E, I got to find the first of T. And when I see the first of T, and I am seeing the first element is E, but there is a two productions. One is this production, one is this production. So first of T will be either the left parent or the int. Okay, so if I see here first of T, that's gonna be the left parent and also the int. And the same thing, okay, will be the first of E. Okay, because first of E is the first of T. Now first of T is this thing. So first of E will be same as first of T, that is the left parent and the int, right? What about the first of X? The first of X again has a two productions, so it will be either the first, that is this plus. So I'm saying first of X equals to, it will be plus or epsilon. Now there is an epsilon also in it. We got to talk more about the epsilon. We'll see it more later on generalization, or do generalization of this. But let's do first examples. Now again we're the first of Y. Now first of Y is simple. This is the first terminal symbol, that is asterisk, and there is also the epsilon, right? Now epsilon has something special to do with it. We will talk that in later bit, little bit. Okay, but what about the first of, if I say these are the non-terminals, what about the terminals here? First of plus, if I want to see the first of plus, that is going to be the plus itself, right? Similarly, first of left parent is left parent, first of right parent is right parent, first of int is int, first of plus is plus, plus first of multiple is multiply, right? So that's not a problem. If I have to calculate, I have to calculate first of the non-terminals. That is the interest we are, because by that we are trying to figure out which one is the first terminal, so that that matches my input token, and I will go by that production which has that input symbol. For example, it's a plus. I will try to see which production first is the plus, so that I can use that production in my prediction. Let us see now the another grammar. For example, we got like this: e goes to t e prime. You have seen these grammars before as well. Plus t e prime, or epsilon, so go to two production for e prime. Now t goes to f t prime, and t prime goes to asterisk f t prime or epsilon, and f goes to id or e. Okay, now what is the first of e? Want to find the first of e. The first of e is the first of t. Now when I say the first of t is the first of f, and first of f is, so I'm gonna first calculate the first of f. That is gonna be the id and the left parent, right? id and left parent. What about that's what is the first of e, that is the first of t. That first of t is again the same, that is gonna be id and left parent, and this is also gonna be id and left parent. What about the first of e prime? That is gonna be plus or epsilon. And what about the t prime now? So first of t prime equals to asterisk and epsilon, right? Let's now generalize these rules to see what we have in the first set. So formally we can say first of alpha, if we talk of any first of whatever, like we say t, e or something, first of alpha, that is t. Okay, that is something like here first of f is id. Similarly, first of alpha, I take the general form, is a t, and that t can be a terminal itself, because like first of star is star, so t can be a terminal. And you know, alpha can go to many steps to the t. What does that mean? I will tell you in a moment. From many steps can go to the t. For example, if we have a form alpha goes to x1 x2 x3 x4, and if x1 x2 and x3 goes to, say for example, to the epsilon, then x4, which doesn't go to x9, its first maybe the t. If you're not getting it, let me tell you in like this. If I say, if say for example I say x1 goes to y1 y2 y3 and so on up to yk, now maybe y1 goes to epsilon, and maybe y2 also goes to epsilon. It may be everyone can go to epsilon. Say for example in a y3, a y3 may go to t, which I was searching for, right? Now x goes to the t, which is the first of y3, but before that it may have from one or many epsilons to go through until it reach that t. So that is this thing exactly, that from 0 to many steps it goes to the t. Then after that it may be anything that I call beta. That's what it is here. Okay, or it may be epsilon. It may be t, may be simply epsilon. If x goes to epsilon, for example, alpha goes to epsilon, for example, then the first of alpha is epsilon itself. Okay, like we are here, if f here goes to say t prime goes to epsilon, then first will be epsilon itself. That is this thing. Or in this case it can also be epsilon if everyone y1, y2, y3 up to yk, everybody goes to epsilon, then overall it will calculate to be x goes to epsilon, because if everybody is gone to epsilon, so x will calculate overall to be epsilon. So in that case also the t will be epsilon, right? So we will have an epsilon here. So this will be the more formal definition for first of alpha. So we can have three things in it. Either it is a terminal, say for example here if you see I was trying to find the first of e prime and it was terminal, and when I was trying to find the first of e, it was the non-terminal. And in this case if you see here, I was trying to find the t prime and it was the epsilon. So I can have three situations. Now these three situations are here. If x is a terminal, then first of x is the x itself. If it is terminal, x is terminal, it's a terminal. If x is epsilon, then first of x is epsilon. But if it is a non-terminal, we got to see the grammar like this, because it may be y1, y2 to the anything. Then we see if y1 is not epsilon, then the first of x is actually the first of y1. Okay, so put first of y1 minus epsilon into the first of x. Okay, but if y1 has an epsilon in it, then put the first of y2 minus epsilon into the first of x. But if y2 is also going to the epsilon, then put the y3 minus epsilon into the first of x, and so on. Okay, and similarly if epsilon is in the first of yi, and I can go from 1 to the k, okay, that is all production from the right hand side, then epsilon, put epsilon into the first of x, because if everybody goes to the epsilon, then epsilon will be in the first of x, right? There are three situations we discussed. First, if x is a terminal, then that terminal is the first. If x is in epsilon, then epsilon is the first. And if we don't have, we have many variables here, non-terminals here, wherever the first we get, that will be the first. If we have epsilons, it may nullify, because if y1 goes to epsilon, then that means it will go off, and so on. And if I found any terminal up front, then I can take that. But if it all goes to epsilon, then epsilon is the first of x. Now if we can't get the first, that terminal symbol from the first, we got to go to see the follow. Okay, now say for example we got an here, for example, we're talking about the first symbol is x. Say for example it derives something, say it derives a to the b, and this is the end, okay, of the first start symbol. So from start symbol everything we get everything from the start symbol, right? And it derives whole grammar, and at the end we put up the dollar sign. So if I say what is the follow of the start symbol, that's gonna be the dollar sign. That will be the first thing. Okay, so for follow we're gonna have many rules. Number one, I said, is dollar is in follow of whatever the start symbol I have, start symbol or start non-terminal, whatever the start symbol, x, s, whatever is there. Second, if say for example I have this x, okay, it goes to, say for example alpha, there is some alpha is the combination of terminals and non-terminals, and then I have b, which I'm interested in. I want to find the follow of b, and after that I have some, again, the combination of terminals and non-terminals, and I want to find the follow of b. This is a situation when I want to find the follow which is in between these terminals and non-terminals. Now follow of b will be what will be the immediate next neighbor, which is a non-terminal, which is a terminal, right? And that is actually the first of beta, right? So if we want to find the follow of b here, that is actually the first of beta, but the condition is beta should not be epsilon. Okay, beta should not be epsilon, so beta should not go to epsilon, right? because if beta goes to epsilon, then that means there is nothing to follow the b. Then there will be some other situation. Okay, now if we have x here goes to, for example, alpha, b and beta, and we have a situation that beta goes to epsilon. Now if we want to find the follow of b, but follow of b should have in the first of beta, but the beta goes to the epsilon, that means it is as if like this: x goes to alpha b, where b comes to, at the end. Okay, so in this case the follow of b is same as the follow of x. If you're not understanding, I will tell you like this. Say for example, we have the x, it was producing something. Okay, something here, say it was containing the alpha part, say this much was alpha, then was your b, and then rest of that is beta. This is the full thing. Okay, alpha is any combination of terminals, non-terminals, beta is any combination of non-terminals and non-terminals, and there is a b. The follow of b is the first of the beta, right? Now if beta goes to the epsilon, that means there is no beta. That means situation is like this: x, this much is alpha, and then everything is alpha, and b is here because there is no beta. Beta goes to epsilon, that means every upfront is all alpha, and then there is a b. So what is the follow of the b? The follow of b is, because b is up to the end now, because beta goes to epsilon, so b is at the end. So what is the follow of b? Follow of b is this thing. This thing is the follow of the x itself, and that is actually the dollar sign, because dollar we say the end, right? So in this case the follow of b is same as the follow of x. Is it or not? Does it make sense? So here if I want to see follow of b, that is same as follow of x, because that is the end when beta goes to epsilon, right? Now there can be the fourth situation where we have directly, we don't have, say for example, x goes to alpha and b, that means there is no beta. After b there is nothing. Okay, it is the same situation like this. So x is having something alpha, and at the end we have b, and we are trying to find the follow of the b that is same as a dollar, that is the follow of x. So in this case also it is the follow of b is equal to follow of x. Whatever the follow of x is, that's going to be the follow of b. Okay, this is the sum of these four situations. Okay, follow of the star symbol is the, because follow of star symbol is the end of the star symbol, that is going to be the dollar. And if we have a situation where we have alpha, b and beta like this, alpha, b and beta, then follow of b gonna be the first of beta. But if beta goes to epsilon, the follow of b gonna be the follow of x, because if b goes to end, okay, then that is the follow of x itself. So what is the follow of a, for a non-terminal a? Okay, so what is the follow of a? It is actually a set of terminals that can appear immediately to the right of a. So the terminal which appears at the right immediately after the a is gonna be the follow of a. Okay, the t should be the terminal, because we are trying to find the terminals, whether it is the first or it is the follow. But if situation is that we have s goes to plus up to something something, and a is at the end. Okay, so if the a is the rightmost symbol in the derivation, then your dollar or end of file is going to be the follow of this s, or follow of a, I mean to say. In the follow of a, then it will be dollar, right? And in fact the dollar is again the follow of s as well. So you should work out diagrammatically this, that if I say s, which is the start symbol, and inside we have something, there is an x for example, some variable which goes this much. Okay, so this is its beginning, that's the first terminal if it is, so that is the first, and this is gonna be its follow, right? So formal definition will be fall of A is going to be that terminal T. So T is a terminal, and S derives from one to many up to ways. Then it goes to the alpha, and when I want to find the fall of A, that's actually the T, right? This T, okay? Or T is the end of file. If your A is the rightmost symbol, it is at the end, then your T is nothing but an end of file. If it is not, if after A there is something, so the first terminal which is after the A, so here the first term which is after the A is gonna be your follow of A. Now look at this diagram, is showing it perfectly. If I want to see the follow of A, look, the follow of A, after A I have immediately the terminal A, so A is in a follow of A. Now if I go here, I'm saying a fall of A because after A I am seeing B, but B goes to the epsilon, so I can't take the B. I have to find the terminal, and therefore I go to the Y, and after Y I see there is a terminal C, so C is in the fall of A, right? Because I want to see which one is a terminal after the A, right? And here the A is the last end of the file, is gonna be the fall of A then, right? Okay, or in this case also, if B goes to epsilon, Y goes to epsilon, everything goes to epsilon, and in that case also epsilon is going to be the follow of A, or we can say S, follow of S is the follow of A. In this case also follow of S, because if you say what is the follow of S, that's going to be the end of file, and that's in our case we put the dollar in as end of file. So dollar is the follow of S, same is the A, follow of A as the dollar. And you should remember this, epsilon is never in a follow set, so never keep epsilon in the follow set, right? Because when there is an epsilon, say for example B goes to epsilon, we don't take it, we go to the next. If Y goes to epsilon, we're not gonna take it, we're gonna take the end of file as the in the follow set. That is gonna be the actually the follow of S is gonna be the follow of that that symbol, right? Even though there is not an end of file, we have some situations that it was not, so say X was deriving A, and the B goes to, and there is nothing in there, and there is something else, and maybe follow of X will be the follow of A in that situation. We'll see those examples later on, but epsilon can never be in the follow set, because we substitute the epsilon to get so that A goes to the end. Okay, so let us summarize our rules for computing follow. We say firstly, if it is a star symbol, S, non-terminal, then dollar is going to be the follow of S. And if there is a production like alpha B beta, then everything in the first of beta, because if we say the follow of B, then the first of beta is going to be the follow of B, right? The follow of B is the first of beta. And if there is a production like this, where A goes to alpha B, because B is the end, or beta goes to epsilon, then that means it will go off and B will be the end. Then the follow of B is gonna be the follow of A. Okay, so same as A. So if this is the end, or after this everything goes to epsilon, then the follow of B is actually the follow of A itself. Okay, so these are the three rules we apply to calculate our follows. This is our the grammar which we talked last time also. We calculated its first also, now we calculate its follow. Let's quickly do the first of it. Okay, here I say the first, and then I may say the follow. Okay, so what is the first of E here? So let me write the first of E. Okay, so that's going to be first of E is actually the first of T, and first of T is first of S, first of F is the left parent. Okay, and ID. So if I say first of F here, it is first of F, that is going to be left parent and ID. Okay, opening parent ID, and the same thing will be of the T and of the E. So T also same thing, parent and ID. It is first of T. Okay, what is the first of E prime? That is plus and epsilon. That is plus and epsilon. Okay, what is the T prime? Asterisk and epsilon. Asterisk and epsilon. Now we will apply our rules, okay, to calculate the follow. This is the first, and now this is the follow set. This is the first set, and if we want to find the follow of firstly the E, okay, so we know by the first rule that follow of the first start symbol is always going to be the dollar. The first thing will be that the follow of E will be the dollar. Okay, right? Because E is something which is a start symbol, and it derives the whole grammar, whatever the grammar we have. So follow of E gonna be the last, that's terminator, or end of the file statement, right? That is my end of the file symbol, that is the end of dollar, right? So dollar is always gonna be here. So let me change my pen. So dollar is always going to be the follow of the start symbol, that is E. Okay, and we had also see, is E anywhere in the productions also or not? Yes, I am seeing E is here. So what is the follow of E? The follow of E is the first terminal after it, and it is the terminal symbol, that is the close parent. So close parent is also in the set of the follow of E. So is E anywhere? No, it's not. So this is our follow of E. Now what is the follow of E prime? Now we have to see where is E prime in my in the grammar. So I'm seeing it here. So it is here. So it is at the end. So the rule this will apply where the B is at the end. So follow of B will be same as the follow of A, right? So this is applied to here. So follow of E prime here is going to be the follow of E itself. So what is the follow of E? We have calculated that already, that is dollar and closing parent. So these two is gonna be the follow of E prime. But we have to see also, is E prime somewhere else? So E prime is here. This is also at the end. Okay, so so follow of E prime would be same as the follow of E prime. So it is of same thing. So it doesn't make any change. Is E prime anywhere? It's nowhere now. So that is the follow of E prime. Now what are the follow of T? Now where is the T? The T is here, right? T is here. So the rule is like this. So it is a kind of this rule where we want to find the follow of B, which is after that is something. So follow of B will be the first of beta. Okay, that means follow of T is going to be the first of E prime. So we have to see what is the first of E prime. That is going to be the follow of T. Now when we see the first of E prime, that is this thing, that is plus and epsilon. We have plus and epsilon. So we will say that follow of T is going to be plus. But when we say epsilon, we can't take epsilon because we know epsilon cannot be in our follow set. But what we have to do is we have to substitute epsilon in place of this E prime. Okay. So if I am saying that follow of T is actually the first of E prime, and the first of E prime is either plus, so that I have written, or the epsilon. That means E prime will go to the epsilon. When E prime goes to the epsilon, that means this is gone, right? So that means T will be the last symbol because this is gone. Now this becomes situation like this: alpha, B, beta. The beta goes to epsilon. That means it is alpha B. B is at the end. It is same as alpha B. So the follow of B is going to be the follow of A, right? So when I substitute here the epsilon, it becomes the rule third. So the follow of T is same as follow of E. So what is the fall of E? Fall of E is dollar and close parent. So I have to add here the dollar and the close parent as well. Okay, close parent and dollar is here. Okay, it's not it's a little jumbled. So let's take this rule again in a proper way. We are seeing fall of T. Now when I say fall of T, what is T? T is here. So that's gonna be the fall, the first of E prime, because it will be like we said A, alpha, B, and beta. It's this situation where B lies between, after B is something. So the first of beta is gonna be the follow of B. So here we have the E prime. So first of E prime is gonna be the follow of T. And when we saw the E prime, its first is plus and epsilon. So we took the plus, but we can't take the epsilon, right? So we'll substitute epsilon in place of beta here. So when the beta goes to epsilon, then this is gone. So it's like alpha beta, right? So A goes to this alpha beta. Now when I say this is epsilon, okay, that means E goes to T. Now the follow of T is gonna be the follow of E. Okay, so when I see the follow of E, that is the dollar sign and the close parent. So I add up here the dollar sign and the closing parent. Okay, so plus dollar and closing parent is going to be the follow set for the T. Now what about the T prime? Okay, but for the prime, so I have to see the T prime. Firstly, is T anywhere? Again, so T is here. Again, is the E prime, the same story. So T is not in the grammar. We have to say everywhere if the T is there. Now what about the T prime? Now, T prime is here, right? So T prime is here. So when you see the T prime, it is at the end. So it's gonna be like A goes to alpha B, and B is the end. So what is the follow of B? Follow of B is same as follow of A. So in this case, same rule here. For the T prime, the follow of T prime is gonna be the follow of T. And we already calculated follow of T. That is plus dollar and close parent. So same will be here, plus dollar and close parent. Is T prime anywhere? We saw the T prime here, and we saw the T prime here, and T prime is if for this rule T prime is at the end, so T prime follow will be the same as T prime, so it doesn't make any difference, and that is it for the T prime. Now what about the follow of F? So we will see where is F. F is here, and after F there is something, so the rule alpha B beta will come into play. Okay, alpha B beta. Eraser. Okay, take this one. Okay, so alpha B beta rule will take place for the follow of F, because F is after F there is a T prime. So what is the follow of F? So it will be the first of T prime. So what is the first of T prime? We calculated first of T prime here, star and asterisk. Again, we can take the star, but we can't take the asterisk. So star is there. So asterisk, we will substitute asterisk to the T prime. So when the beta goes to epsilon, okay, we can't take the epsilon, sorry, I'm saying. So beta goes to epsilon, so it's alpha B, and follow of B gonna be the follow of A, right? So same story will here for the follow of F. The T prime goes to epsilon. When this goes to epsilon, F follow of F will be the follow of T. So what is the follow of T? The follow of T is plus, okay, and dollar closing parent. So this is going to be my follow of this is going to be my follow of the F, but we have to see, is F here also? F is here. In following with the T prime, this is that same story, and there is no instance of F anywhere. So this is my follow set. Now then, I got my first, I got my follow. Now I can construct my table. Before I construct my table using the first and follow, I would like to do more practice. I mean, do one more example to calculate the first and the follow. Let's take this a quick example, that we got the ETX, okay, and the grammar is this, and this is the first of T. The first of T is going to be the opening parent, int, this thing, then if you see the first of E is the first of T. First of T we calculate is going to be the first of E as well. Then first of X, okay, that is going to be plus and epsilon, so that is it. And first of Y is star and epsilon. To calculate our follow, okay, let me calculate firstly the follow of T. Let me calculate first follow of E, because there is a start symbol. We should always start from the start symbol. Okay, so when we say start symbol, dollar is gonna be there. Then we have to see where E is. E lies. Okay, E lies here. Okay, and also E lies here. Okay, so there are many things we can do. So firstly, if I say for this, if I take this E, after the fall of E, that's we have a term as closing parent. So closing parent is got to be here, right? And when I say this, that means follow of X, because it's at the end. So when it's at the end, it is same as the follow of X. You have to calculate follow of X to get it. Okay, let me calculate the follow of X. Now follow of X, where is X? X is here. So follow of X is same as follow of E. So that means we have the dollar and we have the closing parent, right? Now that is the E. I was talking that follow of E here is going to be the follow of X, so that they are having same. So this is it. So follow is dollar and close, follow of X is dollar and close parent. Now we can say follow of T. There's some problem with my tab. Follow of T. So follow of T, what is T? T is here, is the first of X. Okay, first of X is plus and epsilon, so I can say plus, but I cannot take epsilon. 2 is, I will put epsilon here in place of X, so it is gone. So follow of T will be follow of E. Follow of E is dollar and closing parent. So plus dollar and close parent, I got it. And now I have to see more instances of T, but there is one here is the instance of T again. And follow of is going to be the follow of Y. So first I have to wait for this and get the follow of Y. Okay. So where is the Y? The Y is here. Okay. So follow of Y, that's at the end. Follow of Y is same as follow of E. So they are having same. So Y is same as plus dollar and close. So follow of T I was waiting for, follow of Y same, so that is it. So this is the follow of Y. Okay, you got it. Now we have understood how to calculate the first and the follow. I think if you don't understand properly, you got to hit a couple more times and you will get it. And now it's time to construct our Parsing table using first and follow. Now that we have learned how to calculate the first and the follow, the first and follow, the two functions basically which will be required to create a Parsing table. So now it's time for the creation of Parsing table, right? So this is the actually a kind of rule book which will tell us which action we should go do and where to go. Basically it tells us which production rule we're gonna use. So we'll see this in a moment now. So as a parser in general, we'll have a stack and then a buffer when we have the input string, the tokens, and which we want to see whether they are proper sentential form or not. And this is the driver logic which plugs all the things together. Okay, now this will be a deterministic because it tells exactly which production rule we're gonna use. Okay, so that's why we use it here. To create it, we need the first and follow, which we learned how we do that. So now let's try a little bit let's try to understand that why we need to know the first and follow. Okay, say for example A goes to alpha and beta. right? So now, depending upon if, the input, say for example we got an A as an input, will the A belong to this, the first terminal in this alpha, because alpha can be any string of terminals and non-terminals, and this can also be the terms of non-terminal, the first one. Say for example A goes to like this, we have E, and in a beta we have plus, and then we got something maybe E prime, maybe like this. Now if our input token is, say for example we got an opening pair, we are here for example, okay, so because opening pair matches this production rule, so we should use out of this A alpha, okay. If it was not, the first one was the plus, for example here I was on a plus token, I was asking for a plus token, so which production will be better to use for the A will be this guy, that is the beta, okay. So the first guy in the beta, or in the first terminal in the alpha, will actually help me to determine which production rule to use. That's why I have a first set for the A. The first set of the A here, first of A would be the left parent and the plus. So if I have a left parent or a plus, according to that I can use exactly which production rule. Does it make sense or not? Now if we have a first set which is having got a sense here, what about the follow? Why we need a follow? Okay, we need a follow where we have an epsilon. For example, if you see the last example here, we have an epsilon for an x, okay. In the first of an x we can also have an epsilon. That means we can totally skip this. Say for example we have an x here, okay, so this can totally skip because it has an epsilon in it. So if I was trying to find something, if on my stack there was an x, for example like this, we have an x, and if it is at top of the stack, say for example x is on the top of the stack, and I can use an epsilon production, that means it altogether goes off. When it altogether goes off, so it would be kind of situations like this, that we have an x, so it belongs to something, say alpha, and the epsilon, okay. So if I use an epsilon here, so that means we can skip x. So what will be after the x, okay, that may be what will be that called? That will be called the follow of x. Maybe I have on a stack, say for example plus, if I see this here, what is the follow of x? Okay, follow of x is a $sign and the closing parent. Okay, maybe I was asking for here in the input, I was asking for a closing parent. We will discuss as an example this whole input and stack and all things we'll understand, but I'm just telling you why we need a follow. Say for example we were asking for input as a closing parent, okay. So now here is a closing parent, okay, but I have an x as an input, but if you see an x, its first set of an x has plus and epsilon, and closing parent is not there. So but if I use an epsilon, for example, for the x, so that means x does not have anything to say. Maybe closing parent comes where x, okay, because x is here and I got this thing epsilon here, so that means I got nothing out of the x, but maybe a terminal closing parent comes after the x. If it is so, if it is the x the closing terminal follows x, okay, I can use this production x's production to go where x to the closing parent. So I have a way from the x to the closing parent. If I go here, I say x, okay, I am actually having an epsilon in the x. Then if I use the epsilon in terms of x, so this production x goes to epsilon. Now that means it doesn't have, so I have to find a follow of x. If I go here and I want to find the follow of the x, so it's at the end, so follow of x will be the follow of the e. So when I see e here, for example, the follow of e is the closing parent. That means if I basically choose epsilon for the x, the follow of x, where the follow of x I can get that terminal which I was asking for. So that means follow will be you know actually beneficial, because it gets me that variable where that production, so I can use this production only when it goes to epsilon. That means say for example a goes to alpha or beta, the first says that if whatever I'm finding is either in the alphas first or in the betas first, and the follow will be used that what am I finding. For example, I was used to finding the closing parent and where the x, for example, or in this case in the a, where the a production I was trying to find closing parent. The closing parent is neither in the alpha neither in the beta. Okay, if it is neither here neither nor here, so that means can I still use the a production? Yes, if it goes to epsilon I may skip the a, and maybe where the a in the next production in the follow of a I can get this. If that is so, then follow will let me know, because in the follow of the x, for example, here the closing parent is, that means we have an information that if x, where x you choose the production x goes to epsilon, then where x in the follow of x there will be, you can find the closing parent, so you can use this x production as well. Okay, now using this all information we can fill up a parsing table. This is this guy. Okay, for that let's take say for example right now firstly this grammar, and while we have calculated the first and the follow, and let me try to write this neatly downside and try to make a parsing table out of it, and then apply some string, and then apply everything and see everything in action. Okay, now then this is my grammar, and this is the first and the follow. Okay, of these things. Now I'll be using the first and follow to fill up my parsing table, which I have done it already. Okay, so on this side we have all these non-terminals, and on this we have the terminals, and this is actually these things are actually what we have in the input buffer, for example here. Okay, in the input buffer here, and this is the stack. Okay, and that is this thing. This is if we have these things on a stack, we are having E or E prime or T, all non-terminals. These can be on a stack, and these can be on the input buffer. So we are saying that, for example, if I see this option E, okay, I'll start from here to fill my table, that if I have an E on a stack, and if I have ID, for example, if I see firstly the E's first, what is the E's first? That is the opening parent and ID. That means if I have an opening parent and ID on the input buffer, and I have E on the top of the stack, then I can use this production rule. So why can you use E goes to T, E prime here and here? Because if you have an E on a stack and you are asking for example, opening brace, now you go from the E, and the first is the T here, T production. Then if you see the T production, it has the F, and if you see F production, you can get to the opening parent. So where E, you can reach to the opening parent, right? So you can use this production if you want to if you are trying to find the opening parent or even the ID, because from the F you can either go to the opening parent or you can even go to the ID. So that means in short that if you have on a stack E, and on the input side, input buffer side, you have either the opening parent or ID, that's what is in the first, then you put in that entry the production. So this is what we say, that here on the input, if we have the opening brace or we have an ID, and on the top we have here the E. Okay, we have here the E on the top, then which production to use? Okay, we can use E goes to T, E prime, this production, because this tells me, because if you have an ID and E on the stack, I can use this production. If I have E on a stack and I have opening parent on the input buffer, I can use this same production. So this the first will tell me that. And same with the E prime, but E prime has an epsilon, so I have to use the follow as well. So I will finish first the first, then I will go for the follow. So let me forget about the epsilon right now. So I'm saying if I have an E prime on the stack and I got the plus, which is in the first, okay, on the input buffer, my pointer is having that, I have the next pointer look ahead is having the plus and input buffer, then I can use this production plus TE prime. E prime goes to plus TE prime, right? Same happens with the T. If the T is in the input buffer and I got the opening parent or ID, opening parent here and ID here, then I can use T goes to FT prime. And same is with the T prime. That if I have star and epsilon, if I have a star and epsilon, so again there's an epsilon, so forget about epsilon. I will talk this in a moment because I have to say then the follow, right? And same with the F. If I got a opening parent ID, opening parent and ID, and F on the stack, then I can have this F goes to either ID or F goes to E, or no, E in parentheses. So if it is an opening parent, I can I can go to F goes to this opening parent, closing E and closing parent, or if it is an ID on an input buffer and F on a stack, I can go to F goes to ID, right? And now for this, if E prime goes to epsilon, okay, epsilon here in the first is saying epsilon, I have to show the what is the follow the E prime. Follow the E prime is dollar and closing parent. So if on the input side I have a dollar or I have a closing parent and on a stack we got an E prime, I can use E prime goes to epsilon. E prime goes to epsilon. So these are red actually are the follow cases. Same is with this epsilon. So that means if I have to say the follow set plus dollar or closing parent plus here, dollar here and closing parent here, and T prime on a stack, I can use these productions. Okay, I can use this production that T prime goes to epsilon. Okay, because where that I can have, if I use the T prime goes to epsilon, I can have the dollar, I can have the closing parent, I can also have the plus where that root. So I can use the follow set. Okay, now let's work out with an example and try to see that if I how I make a parse table and how efficient working will become. Okay, now let's try an example. You can use any example you like. Say for example I got ID plus ID as an input and I want to see whether this is a as according to my grammar, or is this a perfect sentential form or not, right? So what I will have in a beginning on a stack, I will have the dollar and I will have the E, the start symbol. Okay, and input is this thing ID plus ID, and I put up a dollar on the back so as to mark it as the end of the input. And action, and I will put up a parse tree. So what action I will be using is on the here is my this guy, the grammar. Okay, now if I say firstly the E, okay, so and I have to use the table, this table, to mark an action. Okay, let me change my pen to black. Now what I have to see is the top of the stack. This is the top of the stack on this side, and I have the input marker. Okay, so it will be kind of the situation here. Okay, let me erase it. Now what I have is on the input side here, I got this in my input buffer, I got the ID plus ID and dollar, and on the stack I got only these two guys. One is a dollar sign and one is the E. Okay, and the parsing table, I have to consult the parsing table that hey, if I have an E on the top of the stack and my input is here, my this buffer, consider this as here now, this buffer where I have id plus id and dollar, and I have an input pointer which points to the id, and I'm consulting the table for the action that hey, if I have the input as an id, my input pointer ip is pointing to the id, and the top of the stack pointer is having the e. What rule I should use? So I will consult my Parsing table that hey, if I have on the top of the stack e and input pointer is id, that means e and id, so production rule is e goes to te prime. So as a parsing table I say that hey, if I have an e, I will have to use a rule that e goes to te prime. Okay, now when I use the production rule, okay, what I have to do is I have to pop the e. Okay, on a stack I have to pop this e. That means, and I have to put up the productions there so that this t will be on the top of stack. So that means I will say I will pop the e, and I will push firstly the e prime and then the t, so that t stays on the top, and input pointer stays on id because I haven't done anything with this, so it is same. So now which action I will be using? Again, my input pointer is on id, and now top of the stack is t. So what I have done here is I have popped this e. Okay, my new stack becomes like this, that I got a dollar on the downside and e is popped, and I have put there the e prime and the t. Okay, now t is on the top of the stack and input pointer is still there because I haven't found the id yet. Okay, so I can't say id is correct here, right? The moment I find the id, I will increment the increment pointer to find the plus. Okay, so now right now on the top of the stack is t and ip is pointing to the id. According to that, which production I should use, I have to consult again the table, this table, that hey, I got a t on the top of a stack, t on the top of stock, and id as my where input pointer pointing to the id. So the table says that use this t goes to ft prime. So I will be using t goes to ft prime. That means I will say t goes to ft prime as in a parse tree. Okay, so what I do when I use this, I will pop the t. Okay, and I will push firstly the t prime and then the f, so that f is on the top of the stack. Now I have got f on the top of the stack, and my input is same, input buffer has no changes whatsoever. So ip input pointer is pointing to the id. Now I will consult the table again. I got f on a stack and id on a input side, so I have to use f goes to id as my rule, right? So I have to use f goes to id. Okay, when I use the production rule, I have to pop the f. Okay, et prime is there, it is in fact e prime, sorry. And then I have to put the id here. Okay, and input is id plus id and dollar. Now in this situation, when I have on the top of the stack id and I'm having input pointer same as id, so that means a match. When I got a match, what I do is I will pop id, what is on the top of the stack, and do what? Instruction pointer plus plus, and I will now put my instruction pointer plus plus, and it increments and it goes here. Now instruction pointer will be pointing to the plus. So typically what I have here is I popped the id, that's gone. I discard this as well, so I have because this is match, so I don't so my job is done for the id. Now rest of the string I have to find, so my input will be now plus id and dollar. So typically the instruction input pointer will be pointing to the plus, and the top of the stack is t prime. And when I have a t prime and plus, okay, and plus on the this side, so which production rule I gonna use? Definitely the parsing table is telling me that if you have plus on an input side and a t prime on a On a stack, use the t goes to epsilon. T prime goes to epsilon here. So I'm gonna use t prime goes to epsilon. So that means this goes to epsilon, right? When this goes to epsilon, what that means is just discard this e prime. So I have now only dollar and e prime on a stack, and IP is pointing to the plus. So I have no change in the input here. Now what else? E prime and plus. See the table, e prime and a plus. So it says use e prime goes to plus te prime. So that means I have to use here, here I'm gonna use e prime goes to plus te prime. Okay, so expand this to plus and t and e prime. Basically I found the ID here, okay, and now it's the plus time to find the plus. Okay, now push them here, dollar, okay, because you're using it in place of e prime, so e prime is gone, but you have to push this e prime here on the stack and t and plus. So I have a plus on the top and I have plus ID and this again plus on the top of the stack and plus and input match. So what you do, pop the plus and increment IP plus plus, right? Now you pop it, so typically you have like this situation now, e prime and t, and now plus is gone because I matched it firstly here the ID and now here the plus, and I got only ID and dollar on a stack, right? ID and dollar is input buffer, and on a stack I got a t. Now t is on the top and ID, t and ID, which rule? T and ID, again t goes to ft prime. So the rule which I gonna use here is what was that? Yeah, t goes to ft prime. Okay, in here I'm here, right? Okay, so what I do, I'm saying is t goes to f and t prime. So pop the t, this is e prime, then I got here push the I guess it is t prime, yeah, and f, and on the table ID and dollar. Now f and ID, so f goes to ID, so use the rule f goes to ID, the production rule, f goes to ID. Okay, now what does that mean is simply pop the f, dollar e prime t prime, okay, and now I got the ID, and here I got ID and dollar, no change, no next, ID and ID same. So I matched the ID, next ID, I matched the ID, I matched the plus, and now I matched the ID. So what will be when you do here, you pop the ID, okay, and IP plus plus, input pointer plus plus, right? Okay, you have to extend them. Now diagram is growing. Now that means you used f goes to ID, and then that's gone, that's matched. So you pop it. So what will happen here, you have dollar sign, you got a e prime, you got a t prime on a stack, okay, and here you have the dollar left only. Now t prime and dollar, when there is a t prime and there is a dollar, that is it, you go to t prime goes to epsilon. So which rule you will use here? We'll use t prime goes to epsilon, t prime goes to epsilon. When this is so, you will pop it, you'll just discard it, okay, e prime only, and your dollar here. Now which rule, e prime and dollar? E prime here and dollar, again the e prime goes to epsilon, e prime goes to epsilon. What does that mean? This e prime now goes to epsilon because it has to go to epsilon because I'm done with the string, because my string is done, okay, but I'm not done in my algorithm here, because now pop the e prime, so I got a dollar and a dollar. When dollar is on a stack and dollar is an input, I'm gonna say halt and I am done, right? Because what happened is it's a happy ending because you found the the whatever the input was, it was perfectly according to my grammar, right? If something would have happened that you would have a t prime, or say for example f on a stack, and you had a plus on the input, it will land you here. That means whatever that string is, which which has this situation has come up, that means it's an error situation, right? So I have to use the error handling routine in that case. Now you can use any string and check whether it is grammatically correct or not, using the predictive parser, which uses the parsing table here, right? So on a stack, it pushes on the grammar symbols, and then on the input side, it sees whether the match is not there. If there is a terminal and terminal match, it goes forward. But if it is a some non-terminal, and according to the input, because we have the k as a 1, we talk about the one input, and we according to that we see the table and use exactly deterministically that production rule, and we put our parsing table like this, and this is our parsing table here. So it exactly works in a perfect fashion, right? So I think this is all for the top-down predictive parsing up using the table approach. And now, you know, if you're not understanding it properly, you can recap it so that you will understand properly, and you will get it hopefully. And this is all for this. And next time we're gonna go for, we use it to go for a top to down. Okay, now we're gonna say bottom up. So next will be bottom up parser. Okay, so until then, masalama.